In this lesson, I'll show you how to check the solution of a differential equation. Generally, any function that satisfies a differential equation is called a solution of that equation. Thus, to check a solution, we substitute it and its derivatives into the original equation and see if an identity is obtained. Let's start with question 1. We have, is the function y is equal to e to the power of 2x a solution of the differential equation y double prime minus 3 times y prime plus 2y is equal to 0. So we have y prime and y double prime. This means that we have to find the first and second derivative of our equation, y is equal to e to the power of 2x. And that's not hard to do. Y prime, the derivative of e to the power of x is e to the power of x. So we'll write down e to the power of 2x and take the derivative of 2x, which is 2. This is equal to the first derivative. Now let's take the second derivative by taking the derivative of this equation. We have y double prime this time. And once again, we have 2 times 2 times e to the power of 2x, which equates to 4 e to the power of 2x. I found my first and my second derivative. Now I'll substitute these expressions into this equation, which gives us 4 times e to the power of 2x, that covers this first term, minus 3 times this expression, which is 6 e to the power of 2x, plus 2y is equal to 0. I won't show it here, but take a look. We have 4 minus 6, both are like terms. That becomes negative 2 times e to the power of 2x. And we know that y is equal to e to the power of 2x, so we can replace that with y. Negative 2 plus 2 is 0. Therefore, y being equal to e to the power of 2x is a solution to the differential equation. And also keep in mind, before we move on to question 2, that this is only one of many solutions to the given equation. In question 2, we're asked, show that the function 4x to the power of 3 minus 3y to the power of 4 is equal to c is a solution to the differential equation shown below, where we have dy over dx is equal to x to the power of 2 over y to the power of 3. What I have to do in this situation is take the derivative of this equation with respect to x and then substitute what that is into here. Let's go ahead and do that. Taking the derivative of this term gives me 12x to the power of 2, and the derivative with respect to x for this term gives me negative 12, because 3 times 4 is 12, y to the power of 3 dy over dx is equal to, and the c, which represents the arbitrary constant, becomes 0. Next, I'll solve for dy over dx, and that's not hard to do. I'll take this term over to the other side and then divide both sides by negative 12. This gives me 12x to the power of 2, and on the left side we have 12y to the power of 3 dy over dx. And of course this makes the right side negative. Now dividing both sides, as mentioned before, by negative 12y to the power of 3, I end up with dy over dx is equal to 12x squared over 12y cubed. This will cancel out. And so this, in fact, is a solution to the differential equation highlighted. And there you have it. 2 examples on how to check the solution of a differential equation.